Just one more minute, AJ and you guys. Okay, so what's going on is imagine that electrons are in these clouds, like a beehive around the nucleus. And they are, like we said, the A kids, we learned about energy levels a little bit last week. But the energy levels are just the amount of energy each layer of electrons have. But they really are moving around like bees in a beehive, and they are moving in levels. And like level 1 electrons, there's not very many, there's just 2 of them. And they just have, hold on a second, for some reason, my internet's working slow, maybe. I'm hoping it's working okay. But basically the electrons are living in these levels, almost like an apartment building, and different electrons are different levels. So we have electrons in level 1, level 2, level 3, level 4, just like floors on an apartment building, okay? But sometimes the levels actually overlap each other based on energy, okay? But when you have electrons in these little beehives, these little areas of the cloud, they're in these levels, like level 1, then level 2, level 3, level 4. Some of them overlap, but they're actually in these little bedrooms. And the bedrooms are like in apartments that have bedrooms. So the electrons are in levels, and they live in like a sub-levels. We're going to call them sub-levels. And that's like an apartment in a big apartment building. Okay. So if you're like, I'm in level, like I'm on the 10th floor, you know, of an apartment building, and I have my own apartment, and then I sleep in a bedroom. And that's what this is. These are little tiny spaces of where 2 electrons can live. And we have an S type, and that's spherical. That's this letter A. And the B type is more like a dumbbell shape. And this is a P type of sublevel. And this is a D type of sublevel. And this is an F type of sublevel. And there's only 4 types. Now, in theory, we could have even more. We could even make bigger and bigger atoms. But right now, we only have 7 levels of electrons, 7 floors in an apartment building. We have 4 types of apartments, or 4 types of sublevels. And each sublevel, some of them have only 1 bedroom, some have 3 bedrooms, some have 5 bedrooms, some have 7 bedrooms in these apartments. Okay, so it's kind of relating it to a big apartment building is really what it is. Okay, so electrons are moving around in 3 dimensions in this sphere, and these are called S's for spherical. This is a P type, and they're P's, and you can have up to 2 in each one. But in the type of apartment for P's, you could have 3 bedrooms, three types, 3 separate little places of sublevel, 3 types of orbitals. Okay, so these are called orbitals that are in sublevels, and sublevels that are in levels. Okay, so we have S type, P type, D type, and F type. And we're really only going to be really concerned about the first 3. There are some F sublevels, and they're down in the bottom of the periodic table. But we're going to mostly focus on the S, spherical, P, that is dumbbell, and D, that look like a flower. Okay, so that's going on with the types of orbitals. Okay, so what we're doing is we're going to be writing out their address of where they're living in these levels, sublevels, and orbitals. Okay, so now with the document camera, I'm going to move over, and I'm going to try to not present so I can mainly focus on the document camera here with my hand, and then try to hopefully figure out how to just present from there, or just get the full screen. I'm hoping the change layout would be auto, maybe tiled, spotlight. And I'm going to spotlight. I'm not sure how to spotlight you, not you, but the other one. So maybe I'll figure this out, change layout. I'm going to figure this out here. And we're going to do this one. And I'm not sure how to get it. Not quite sure how to get just my thing going. I'm going to just talk here and hopefully you guys can see my screen enough, okay, with what I'm going to do here. And I'm hoping this is enough. I'm going to close this out here. Nobody's seen it more. Okay, so what we're going to do is on this page, we're going to use this page and we're going to use maybe refer back to this page just to try to go through the organization of it, okay? And then also we're going to use the blank periodic table, and that's going to be really crucial because this is going to be your cheat sheet, okay? This is going to be your cheat sheet, and we still have a good 30 minutes to go over this, okay? So today I'll probably go over the first, first maybe 3 levels of electrons, elements possibly, and then we might break and make sure we can go through some of the questions on the homework packet. So this is the notes. This is inside the note packet. And then I want to go over, and this might be more of an honors packet, but I don't know if I have it, but this is almost like your homework packet, but it's not quite. But if we don't do it today, we will definitely go over homework tomorrow, more so tomorrow, okay? I thought I had it with me up here, but I don't necessarily see it, okay? So let's go back and just look at this table on this page of your notes, okay? Basically, we're talking about orbitals because orbitals is the lowest type of organization with electrons in these levels, okay? And it's more like, where would you look for a bee? It would be in a hive, okay? And so the hive for bees is like electrons. Orbitals are to electrons, okay? And orbitals are the regions of space where there's a high probability of finding an electron. We're talking about a 90% chance of finding an electron. Each orbital can have either none, which is 0, have 1, or have up to 2 electrons, okay? No more than 2, okay? And they have different sizes, shapes, and names, okay? So basically, orbitals combine to form sublevels, and sublevels come to form levels, okay? So in this type of sublevel, you have S. There's only going to be one type of orbital up to 2 electrons. And you have to be levels 1 through 7, okay? So every single level has this, okay? And I'm sorry, I'm not right there, okay? And we've got these spherical type orbitals. They're basically spherical, okay? So it's like a sphere, okay, in 3 dimensions. And you can have up to 1 or 2 electrons in there, okay? Now, P's have up to 3 orbitals, and they can have anywhere from 1 through 6. And you're going to have a P looking like on the X or X type X and Y. There's one here on the X. You could have one on the Y, and you could have one on the Z. And what's going on is there are 1 electron or 2 electrons in this type of space. There's 1 or 2 electrons in this type of space. And then you could have 1 or 2 electrons in this type of space, okay? And so you can have one going left to right, one going up and down, and one going diagonal back and forth. And you can only have these in levels 2 through 7, okay? And then we're going to do D's. D's have up to 5, and F's have up to 7. And that means you can go anywhere from 1 through 10. And F's can be 1 through 14. And you can only have here, and they're like a flower shape, and you make 5 of them. There's 5 different flower shapes. I could show you more visuals if I could. I mean, it's in my internet files, but I'm not going to save time, because basically look at this guy like a flower, this guy like a dumbbell, this guy like a spherical. And you're going to have levels only 2, 3 through 6 on the periodic table. And F's are only going to be levels 4 and 5. Okay, now where in the heck are these on the periodic table? Let me go ahead and show you on your blank periodic table. Okay, so we're going to identify these areas on your table because your table is going to be your friend and your guide. Okay, now you guys are going to have a table with all the names and whatnot, right? Knowing what boron is and calcium and iron and whatnot. So this one's going to be blank because we're going to fill in how you do the configuration. So this area of the periodic table is going to be, and I'm going to add in helium here. We could put helium here or we could put them over here. And I think for today's lesson, we're going to put helium right here. Okay. But this whole area is called the S block. This is all of the S's. Okay. So this whole area that I'm marking right here is the S sublevels. Okay. The electrons, each one, see each element down here, if you look at the names of the elements, okay, these here, hydrogen, helium, and then lithium, beryllium, and boron, and neon, and whatnot. They're all adding on one electron each. So hydrogen has 1 electron, lithium has 3, sodium has 11, calcium has 20, and it's the same as the atomic number. The atomic number is a number of electrons. Boron has 5, fluorine, I think, has 9. Each one of these has a building number of electrons, okay? So what we're representing here is the final electron and what sublevel does it end in. So we have the S sublevel, okay? And this area, we're going to call it the S block at times. We can call it the S block or the S sublevel. And it's going to be having 1 orbital, and you can only have either 1 or 2 electrons. Okay, and we're going to call this 1s. We're going to call this 2s because it's in the second row. And in fact, these are the levels. So go ahead and mark these. This is level 1, level 2, level 3, level 4, level 5, level 6, level 7. At the moment, we only have 7 levels. There are elements after 92, right about here. All of these right here after uranium, up to 92, they've been found in the world. But after 92, they begin to make them from like NP all the way here and all the way for the end of the 7th row. They're making elements. So they actually have made up to 118 elements. And somebody out there in the world is wasting science money. Not that it's not to them wasting, but I think money should be saved and used to solve for cancer and solve for sickness in the world. But they are making probably this next level of electrons, level 8, but it doesn't matter to us because I want you to understand the first 7, okay? So this is the S block, and so this is level 1, so we call it 1s. This is level 2, so we call this 2s. This is level 3, so we call it 3s. This is level 4, we call it 4s. Level 5, we call it 5s. Level 6 is 6s, and obviously this one's 7s. So that means when you compare it with the elements down here, lithium's last electron is going to be in the 2s sublevel. If we jump down to cesium, it's going to have its last electron in the 6s sublevel. If we do potassium, it's going to be in the 4s sublevel. Okay, and that's how you know because you're labeling the region. Okay, and so we know that S's have 1 orbital up to 2 electrons. That's why it has 2 columns on the periodic table. So when we do P's, we're going to have up to 6 columns on the periodic table. And if you go over here, we're going to mark this area. This area is going to be the P block. So I'm going to mark this whole area is going to be the P block or the P sublevels. Okay, the P sublevels. And we're going to put this whole region is the P sublevel. Okay. The P sublevel. And again, we don't have a 1P because levels 2 through 7 are the only ones that have P's. So we're going to have them really funky dumbbell shapes. The S's are spherical. They just get bigger and bigger and bigger from lithium, sodium, potassium. All these guys just get bigger S sublevels. When we do the P's, they're going to look like these dumbbell shapes, and we fill them up, and I'll explain more about filling them up on another video. more maybe tomorrow, or it's going to be your Wednesday video next week. Okay. So this is going to be 2p, label 2p. That would be boron. Boron would be 2p, and boron through neon would be 2p. And then aluminum through argon is going to be 3p. And gallium through krypton is going to be 4p. Indium's last electron through xenon's last electron is going to be 5p. When we get to the next row, it's going to be thallium. Oh, excuse me, Sprite, 6p. My bad. That's 6p. And then these new elements, I don't even know their names. They're brand new. They don't live very long. Again, everybody after uranium, it doesn't live very long. They're radioactive, unstable, big, massive physicists want to make more. And I know it's important to their world, but to health reasons, I think they need to put their money somewhere else. But we do have these man-made elements, NH, FL, MC. I don't even know their names, but 7p is that region. Okay, so you're going to go from NH to AOG. That's these last set of elements are going to go 7p over to the end. Okay, so that region 7 is p sublevel. You can have up to 3 orbitals. Okay, you can have up to 1 through 6 electrons. Okay, so you can't have any more greater than p6. We're actually going to write it like a power. We're going to write it like S1 or S2, like it's a power over here. Okay, so you're going to write it like a power over here. You could have P1 through P6, and we're going to write it like a power. Not that it's a mathematical power, like P to the first power. It's just the way it's represented. Okay, and then we're going to be doing the D's, and the D's start at level 3. But there's something funny about D's, and there's 5 of these guys, okay? There's 5 of them. They look different angles and so forth. And then there's even a funky, weird one like this, a really weird shaped one, okay? But what's going on is these guys actually jump one level. They jump up one level higher, okay? These guys jump one level higher, and then the F's jump over 2 levels higher. And it's kind of about their energy. They have more energy. They have more energy. That's why I'm putting it like this. They have a lot more energy for F's. And so they go to the jump one. It's actually one level higher. Yeah, that's about right. So what's going to happen is that we're going to do the D's, but the D's are going to be not in the 3rd row. They're going to be in the 4th row. So we're going to put 3D here. And then we're going to put 4D here, even though it's in the 5th row. We're going to put the, in the 6th row, we're going to put 5D, and the 7th row, we're going to have 6D. And that's because the D's have more energy than their S's. So they jump around into the next row. They actually kind of overlap. So I'm going to make this a green section, a green area, and it's going to be the D section. So we're going to make this 3D. Oh, sorry, not 3D, just D subblock, the D sublevels, my bad on that. 3D sublevels, okay? And we can have up to 5 orbital types, 5 orbitals, and it can have anywhere from 1 through 10 electrons, 1 through 10 electrons, okay? And then this section down here at the bottom, which I don't even think I have any more colors. Actually, I have an orange color, okay. So this bottom section, we're going to make this the F area. These are the F's. And this is going to be the F sublevel. Okay, it has up to 7 orbitals, and it has anywhere from 1 through 14 electrons. Okay, and it's this section here. And so we're going to call this 4F and 5F. But really, we have to rip open the periodic table, and this section should go right in here. This section should go right in here. And if we get a chance before we leave, I know we have about maybe 10 minutes. I can show you a visual on the internet once I get out of here. So I'm going to try to help you understand how to write out possibly up through argon in the next 10 minutes. I'm hoping to. but this is your chart. And we're going to come back to this chart here to use as a guide. Okay. The other thing here, you can mark this 1S and mark this 1S. And also over here, you can make this little box of helium also blue and make him 1S if you want to keep him over here. The reason why he's over here is because all of these guys have a full level of electrons. This is really important. And they're also called the noble gases. These are called the noble gases. And a lot of it is because they think they're too good to be making bonds with other elements. So a lot of times the scientists who came up with these funky names, they basically say these guys don't react with anything. Okay. And we'll kind of explain that over the next few days. So anyways, with you guys that are here, Alex, I know you joined in. I just saw you joining in. I don't know when you joined in, but I'm hoping that you had your blank table that you could follow me. We filled in this table a little bit more and clearer. And now we're going to be going into how to write out the address of the simple elements. And maybe we only get to neon because I want to show you a couple visuals from the ptable.com to kind of visualize how the F's are actually ripping right here. They're in the 6th row because these guys jump 2 levels. Okay. So let me know, is there any questions? I know I went kind of fast here. Anybody got any questions? Are you guys doing okay?
Is there a chance that I could take a picture of that at the end?
Sure. You can take it right now, actually. Let's just do that.
Okay, thank you.
Feel free.
So it goes S, D, P, and then the bottom is F?
Yes. But you want to focus on S's and P's till you get up to argon. And then when we get into this middle section, we're actually going to call this middle section, we're going to call these transition elements or metals. So if you want to call the D section transition metals, go ahead and call them that. Also, the S's and P's are going to be called the representative or main elements, because they behave normal and don't cause, they're very predictable. Okay. And then we're going to call these F guys, these F ones, we're going to call these inner transition. Now, some of these terms we're going to actually use more on our next unit in chapter 6. Okay. But I just wanted to label that I might call these guys transition metals. Then S and P's are called representative. And we talk a little bit about valence electrons, but that's more, and I will bring it up. And this is like on Tuesday's video, but I don't know if I did Tuesday's video very clearly. So this is really what we're doing right now, Alex. I know you're in the B group, or no, you've been home though. You've been home. So I don't even know if you've seen any of my videos from last week's folder, but if not, I would, and that goes for Rod and AJ too. Mondays is when you're trying to clear up this part of the notes, Mondays. And there was a set of questions going over the history of how we went from the Bohr model into this quantum mechanical model right here. And then the Tuesday video, I'm trying to explain this, probably not as clearly as I did right now. And then I'm going to start doing some examples. So I actually have a few minutes. I can probably get to neon to explain it and maybe even start, sodium or magnesium before we leave. But I'm going to end the recording. But this part of what I'm covering, like especially this and this is on Tuesday's video last week. And then there's a Wednesday and a Thursday. And for AJ, Rod, and all you guys, because you're A kids, I'm going to make it your Monday, Tuesday, Wednesday video next week. This stuff here, the stuff that it takes about 3 days to teach. So the videos that the B kids had last week, you guys are going to actually look over next week. So you're even going to have next week to work on all this stuff too. If that makes any sense. Okay. Yes, it is in your packet, Rod. This is, if you take this packet, I don't know if it started with this history part, But this paper, I hope to have gave out. I thought I gave out Wednesday, Thursday, or Friday last week. But honestly, you could probably get a sheet of paper out and follow me, and you don't even need this paper because it's pretty much, I'm writing everything out. So if you don't have the paper, feel free to get a sheet of white paper out, get notebook paper out. You'll be fine without it. Okay. The only time it might be helpful is having these pictures of arrows. But if you need me to send you a copy of this, I could do that. Rod, let me know, especially this page here. Okay. Okay. So what we're doing here is we're going to take this pattern of what's going on with the different levels and sublevels, and we're going to write the address of the electrons and call it their electron configuration. And what this does is it tells you how they're arranged. We always use the location of the element in the periodic table to help us write it correctly. And that's what we're using this for. So if we just do hydrogen, it's just got one electron. This is the Z value from last week, but it's the number of electrons, and there's only one. Helium has 2, lithium has 3, 4, and then boron has 5, carbon has 6, nitrogen has 7, oxygen has 8, fluorine has 9, and neon has 10. So we're going to follow these 10 electrons, and eventually we're going to get over to here on your chart and explain it. Okay. So when we do these first 2 electrons, we're going to write down the level, and that's the 1 that represents the level. We're going to write the sublevel because we have an S. We have an S here. Okay. And that's the S sublevel. Okay. So we're going to put 1S, and that's the sublevel. Okay. And then we're going to write the number 1 because there's only one number. That's just the number of electrons in that sublevel. Okay. And so that is hydrogen's configuration. It's just 1s1. We're not really going to treat it like a power like you do in algebra class or math class. It's just called 1s1. And so we're going to put a 1s1 in our periodic table like we're doing here. We're going to put the power number in to represent that box. So hydrogen is 1s1. And then helium, whether you draw him here or over here, he's the second box. So we're going to put 1s2 here or 1s2 here. And that's the ending of the sublevel for that first level. So in the apartment that the hydrogen helium has, it basically just has one level, and he has one bedroom, and he has up to 2 electrons. And that's what's going on. And they basically look like a sphere with 2 electrons moving around. That's what hydrogen helium have. Okay, so you write helium as 1s2. Okay, that is the configuration for helium, like right here. Now, when we go past helium, we're going to then begin to write the 2s. And eventually, when we get to boron, we're going to say 2s and 2p. Because each time we build on, we're going to keep writing the same thing. Because the inner 2 levels is always going to be like helium, and you write down 1s2. But now we have a third electron, but that third electron is in 2s, but we're going to say 2s1 because lithium is the very first box. So you're going to say lithium is 2s1, but beryllium, you're going to say 2s2 because you're the second box. And each electron is adding on. Lithium has 3, beryllium has 4, boron has 5, all the way over to 10. So each one's building on another electron. It's building on the protons too, but now we're only focusing on the electrons. So we're going to write 1s2, and then we're going to write 2s1. And this 2 and the 1 should equal the 3 because the first 2 are in the helium, 1s2, and then you write 2s1. Then for beryllium, we're going to write 1s2, but since beryllium is the second box, we're going to put 2s2. Just like I'm doing right here. We've got 2s1 for lithium, 2s2 for beryllium, and we're going to write it down like this. And so the 2 s's and the 2 s's here add together to equal 4. Okay, and s's can have only up to 2. P's can have only up to 6. And once you get past it, then you have to go to the next sublevel. Okay, So now, once we're now past this, you're going to keep saying 1s2, 2s2. And so we're going to write these down. I'm underlining because that's what you're going to be writing down as you go to bigger and bigger elements. So when we do boron, we're going to continue the 1s2, 2s2, because that's the first 4 electrons. And then we're over here in the p block. So for boron, we're going to say 2p1. We're going to say 2p1. And then if we go on to carbon, you're going to say 2p2. And then for nitrogen, you're going to say 2p3, because you literally count the boxes over to it. So we're going to write out boron 1s2, 2s2, and then 2p1. And that adds up to 5. That adds up to 5 electrons, 2 in the first level, and then this is the second level. So we have 2 in the first level, and then we have 3 in the second level, because literally he's the third box over here. Okay. Then we do carbon, and carbon's going to be 2p2, and then nitrogen's going to be 2p3, and oxygen's going to be 2p4, because I'm literally counting over. And then we have 2p5, and then neon is going to be 2p6. So we literally write out this 1s2, 2s2, and then we're going to write 2p2, because we have 6 electrons for carbon. We're going to write 1s2, 2s2, 2p3 for nitrogen. We're going to write out 1s2, 2s2, 2p4, and we're literally just counting over the boxes, okay? And we'll keep going and get to neon. 1s2, 2s2, 2p5. And let me know what your questions are with what I'm trying to explain here. 1s2, 2s2, 2p6. Feel free to ask questions, okay? And this is the beginnings of learning about electron configuration. And in the video that I made for Tuesday, that's posted for Tuesday in the folder right now, I actually go down and explain level 3, but we can start at level 3 tomorrow. That's not a problem. I can start there tomorrow. Okay. So the one thing I wanted to show you real quick is in this periodic table site on the web, it's really helpful, and it kind of shows all the different types of, let me show you real quick here as I switch over. And we have this site called periodictable.com. And if you go there, it actually shows you the electrons, the situation. And here it has all the levels here. So if I do hydrogen, you can see that it's only 1s. But if I go over to neon or fluorine, it then fills in. And these are arrows, and I'm going to explain the arrows tomorrow. But the one part I wanted to show you is the P is the S block. The pink is the S block. I'm sorry. The green is the P block. The yellow is the D's, and the blues are the F's. And I wanted to really show you this widening effect. And I bring it up in Wednesday's video that I made last week. But if I go wide, you begin to see it all move around. It takes a minute because my internet's so slow, but do you see how it all spreads out? And again, we have the S's from 1 to 7. The P's are level 2 through 7. The D's are actually jumping ahead 3 through 6, but they're levels 4 through 7. And the F's are right here beside barium and radium. And the F block, instead of being down below, we're putting it in between. So I wanted to show you guys that, okay? Now, I know you guys probably have to get on to your next class. Let me get over here to the other page so I can see you. So if you have to get going, I understand. And let me know. I'm hoping that I helped. There is homework to start working on page 1 and page 2. And I don't quite have that page here, but it looks a little bit like this section here. I know that this top question is a little different, but I would try to work on this page and then filling in your elements on this page. And also, if you need to get together tonight, just send me a text. I'm going to do a little bit more of the configurations, but also spend time on the homework tomorrow. Okay. So let me know what your questions are. If you have to get going, feel free to go. I'm actually off right now, so I'm not rushing to another class. So if you do want to look at some of the homework, or if you do want to work on anything, feel free to stick around. But if you have to go, that's fine, because you might have a math class during third or an English class. Or I don't want to take you away from your other classes. So I'm going to go ahead. So let me know how I can help. If you do want to stay, you're welcome to help. I'm just going to stop recording now, because whatever